Y'all ever have one of those days where it just seems like nothing goes right? Kind of starts in the morning and it feels like it just follows you throughout your day. Yeah, it's kind of how I feel about yesterday. And that, even carried on over into class. If you watch yesterday's video, you're going to see me make some faces probably pretty much every time that I calculate a number that just seems out there throughout that presentation. So let's just jump into basically a redo of yesterday, right? So let's get into that. So last time, we put in our road, we did some basic calculations of the overburden and that sort of thing. But when we were doing it, the first thing I was like, man, a 400-foot bench, that just does not seem realistic. And so I must have messed something up in the numbers that I chose or something like that in the project, right? But I'm just like, this is not realistic at all. I was also debating the 18-degree slope. I thought that seemed pretty low. And I went back and I recalculated, some of the slopes along here, and it is. So what happened there was, when I was calculating the slopes, I calculated them in degrees. But for whatever reason, I thought that I had done it in percent. And then I converted it into degrees. So, if you've already started, that's fine. Just keep doing what you're doing. You can use the same numbers that you're already using and just run with it. I'm not going to, penalize anybody for that, of course. But if you wanted to use more realistic values, I have updated the problem statement to reflect that, okay? So instead, it's now saying 33 degrees in the north and 44 degrees in the south. Much more realistic. Also, I was using the $100 per ton sale price for the coal instead of the $60 per ton after the mining cost in my bench calculations. I did not put this in here as an intended trick question, but I definitely tricked myself with it. But my original, intent of labeling it this way was to show that, yes, there are, significant costs associated with mining coal that are not directly associated with the removal of the other overburden, and that those should be taken into account, and definitely will be if you're doing a feasibility study or something like that. But instead, we're just saying it's this much. Remove that from the 100, and you get $60 a ton after the mining costs. So that was a mix-up. And then again, with beta, for whatever reason, I used it correctly in the denominator of this equation, 90 minus 90, being 90 being beta. But for the sign, the numerator of the equation, I was thinking of vertical angle, and I said it was 0. So both of those things, several things, led to us having unrealistic bench widths and that sort of thing from yesterday. But let's try that again, okay? So if we solve for the maximum bench width for the parameters given for the Northern Reserve, we have our conversion factor, our constant there at the beginning. And then we have $60 per ton, not the $100 per ton, which is then divided by $5 per bank cubic yard for overburden removal cost, right? Our 3-foot coal thickness is, what we used last time. 80 pounds per cubic foot is our density that we're using. And now we're taking the sine of the 180 minus 33 degrees for the Northern Reserve, or 18 if you're using the old number, minus 90, right? So that was not originally taken into account. And then we're dividing all that by the sine of the angle, alpha, 33 degrees, and the cosine of beta, 90 degrees minus 90, which is 0, and the cosine of 0 is 1. So you do all that, and you get about a 120-foot wide bench, which is much more reasonable than 400 feet, right? So We can also calculate the associated high wall height with that. That's just the 120 tangent of 33, which gives us about 78 feet, or we can just round that to 80 for the purposes of this. For the Southern Reserve, we can also do that same calculation again, right? We're using 4 feet this time instead of 3 feet, and our angle is now 44 degrees instead of 33, or I think it's 24 if you're using the old numbers, which, like I said, that was fine. Then we do that calculation again, and we get a maximum economical bench width of 107 feet. So a little bit shorter, right? A little bit shorter because of the increased steepness of the surface topography. Our high wall height associated with that is 103 feet. So basically right at 100 feet. That makes sense because our angle is close to 45 degrees, right? So they should be close to the same. And so this is more reasonable, and it also, just barely exceeds that sort of arbitrary cutoff we used yesterday. I shouldn't say arbitrary, but a sort of, a historic, cutoff. Okay. Now, for the area previously deep mined, we can do that too, right? We can do that all over again. We've got, our mining height, and our surface slope is the same, 44 degrees. We kept that the same. Our mining height, though, what I did was I took the mining height and then I multiplied it by 31%, right, which is the amount of coal that's left if 69% has been extracted. And when we do that math, you get an equivalent coal seam thickness of 1.24 feet. So if it was in place everywhere and not, mined out in these rooms and pillars, and it would be that thick, right? So, and we can calculate a bench width based on that, and it's 33 feet, right? And our high wall height is roughly the same. So, yes, you could mine this if you wanted to. Okay, go in there and mine, around that mine and mine those pillars out and that sort of thing. But you are going to be quite limited with these bench dimensions, right? What I'm basically saying is the bench dimensions that we calculated for the other parts of the mine, you'll have to have smaller equipment here most likely to mine this area. It's not going to fit what you had over there. So in that case, if it was me, I'd probably just not even fool with it. There's probably not enough there to get. Now we get our map back up again. And so the areas that we calculated, the previously mined area, the dark blue hatch, okay, the newly mined area, right, the cyan hatch here on the north. So what was already gone, what we're going to get, and then everything down here to the south, here in this cyan, with about 100-foot high wall height. Here, right in this low gap, I did put in a couple lines for a box cut here, as opposed to trying to just stay on this contour. Most likely what you would do in here is just put the cut in, right? And then get this coal out and then just start working your way around. So with that, we can move on to how much overburden we have to remove, right? And the way I found my areas is I clicked on those hatched areas. I use BH is the command, batch hatch, where you can hatch multiple things and it all becomes one, right? And so when I go to the properties in AutoCAD, you can just type in properties or prop and it'll come up. You can find the area of those hatched zones. And AutoCAD determined that the previously mined area was 990,000 square feet, and the newly mined area was 902,000 square feet. We'll have to convert those sort of into acres, right, when we design the drainage pond. But for the time being, I left them as square feet because I then converted them into cubic feet, right, by multiplying by the average overburden thickness. So in the north, remember what was previously mined, it ranged from 0 to 40 feet of overburden. We're moving an average of 20, right? And so that gives us about 20 million cubic feet, which is about 3/4 of a million bank cubic yards. And then if we multiply by the swell factor, 1.25, we then get just over 900,000 loose cubic yards, right? And that's for what's previously been mined. What's left, okay, that area was about 902,000 square feet, a little bit less. The average overburden is 60 feet, right? 40 to 100, average is 60. That gives about 54 million cubic feet, which turns into, divided by 27, we get about 2 million bank cubic yards, or about 2.5 million loose cubic yards, taking into account the swell factor. So if we add those two together, in bank cubic yards, right, we get about 2.7 million bank cubic yards. Now that represents the amount of storage area on that bench that there will be after we take the extra overburden off of there, right? Our recovery, we can calculate that in tons with our newly mined area, A sub n, multiplied by the thickness of coal, multiplied by the density, the 80 pounds per cubic foot, divide that by 2,000 pounds per ton, and we get about 108,000 tons in that northern reserve. And we can do the same thing again for the southern reserve, right? That cyan hatched area is about 2.7 million square feet. Average overburden is going to be 50, right? 0 to 100. And we get about 134 million cubic feet, which is about 5 million bank cubic yards, or 6.2 million loose cubic yards, right? We can take into account our previous, bench, storage area, for the overburden. Add that into our calculation here that we got, the 5 million bank cubic yards, right? And we're right at 7 million bank cubic yards of overburden storage capacity on the bench itself, right? So if we take how much loose cubic yards we're removing from both areas, the 2.5 million and the 6.2 million, and we subtract the 7 million cubic yard storage area, we're going to need a fill of roughly 1.75 million cubic yards. And that will be, what we'll sort of draw in for the valley fill over on Isaac's Creek, right? So we'll put that in at a later time, but we're doing the calculation now, and I need an extra L in fill. Jeez. Anyways, I'm just going to leave it. We can also calculate our recovery here. We have our that average area, 2.7 million square feet, multiplied by the thickness of the coal, in this case 4 feet, not the 3 feet from the previous reserve, multiplied by the 80 pounds per cubic foot, divided by 2,000 pounds per ton, and we get about 428,000 tons, 429,000 tons here in the southern reserve. But add in the others, and we're, about 535,000 tons, right? We're over 500,000 tons of coal on this property. And finally, showing the map again, one last, sort of step here to just remind you that, we have calculated the amount of overburden that was removed from here, what will be removed from here, and how much storage capacity we have on the bench, and our fill volume. Okay, so that's what we're sitting at here. I'll get back with some blasting calculations for the north, and then we'll start calculating our pond sizing and that sort of thing, and just replace this with yesterday. And we'll see you next time.